Hello everyone, thank you so much for tuning in to Code with Yazid. My name is Yazid and we are looking at the first project for FreeCodeCamp's algorithms and data structures certification. So this video series I'm going to do will cover each project in the certification. So if you do enjoy the content, please like, subscribe, and share. I'd really appreciate it. I'm also on Twitter at YazidB. All the links will be in the description. So this first project is a palindrome checker. A palindrome, as we can see here, is a word or a sentence, just some amount of characters that reads the same forwards and backwards. And we're going to be ignoring punctuation like commas, periods, question marks, exclamation points, casing, all these things. We're actually going to strip this out when we do the comparison. So for example, if you had the word race car is spelled R-A-C-E-C-A-R, forwards and backwards. That's a palindrome. Even if it has extra spacing or punctuation or underscores, it's still a palindrome because we wouldn't count any of those. So if you scroll down, you can see all of the test inputs that our function is going to be given. All of them have to pass if you want to complete this challenge. Like, for example, we see two different forms of the word I here. One has an underscore, one doesn't. They should still both be palindromes. Obviously, the string not a palindrome is not a palindrome, so your function should return false. Surprisingly, a man, a plan, a canal, Panama is a palindrome, and oh wow, even this string is a palindrome. I guess that's because if you take out the underscores and the space and all the characters, you are left with 0, 0, 0, 0, which reads the same forwards and backwards. So yeah, that should return true. So let's get started on this. The first step, and I advise you always do this during your coding interviews and your projects, is to step away from the code. Code should be the last thing you do when solving a problem. Why? Because a lot of times our nerves, they get the better of us. We're in a pressure situation and we have to deliver, so we begin frantically hacking out a solution and code ourselves into one brick wall after another until we stumble upon something that kind of works, and by the end of it all, we've torn our hair out, if we even had any hair left. So let me suggest a better way to you. If there's anything that I've learned over my few years as a developer, it's that coding should come last. You have to think about the problem before you worry about how you're going to do it in JavaScript, Python, or whatever language you're using. Once you've come up with a solution and you have the steps that your algorithm is gonna undertake, then the syntax is easy to Google. Code is the easy part. Always remember this. Code is the easy part. Finding the solution to your problem, that's the hard part. And this is why developers can still get jobs, because anyone can hire a code monkey. But the hard part is what happens in our minds and on the whiteboard, in the notebook, right? It's our ideas, it's our approaches to solving problems. That's what gets us paid. That's what gets us jobs, not what we do in the code editor. That's just characters we put in a program so that our computers understand what we want to do. It's really just a translation layer. I used to be one of those programmers who would rush into implementation, and I'd keep hitting one brick wall after another. I've face planted so many times I hardly recognize my face anymore from how many times I've hit myself. But I've learned to calm down and think about the problem more. And that's how successful coding interviews go, by the way. That's how the job goes too. I speak to my seniors a lot at work to pick up as much wisdom as possible, and they are unanimous in saying that coding should come last. Before they write a single line for a new feature, they open up some sort of text pad or a notebook or even a whiteboard somewhere in the office and just start recording their ideas and their thoughts. They theorize, they draw up solutions, and figure out how to test them. And this is where the bulk of your time should be. Then, when they feel confident about it, they start coding, and by that point, they're probably done within half a day or a day or two max, because all the hard work is already complete. Code is the easy part. Now, with that being said, let's think about our problem before we write some code. So we have to write a function that determines if a string is a palindrome. The casing does not matter. So probably, I'm going to go ahead and delete this boilerplate here. Probably the first step is we are going to lowercase our input. We are going to make sure that every character is a guaranteed consistent casing. It can be uppercase, it can be lowercase. I personally choose lower. That's just what I usually do, but it doesn't matter which one you choose. So this seems like a good first step. Next step, we only care about alphanumeric characters. You can see here in the notes, you'll have to remove all non-alphanumeric characters and make everything the same case. So I would flip around that order of operations. I think it's a little easier to lowercase first and then strip out the bad characters, and I'll show you why in a second. But for sure, step 2 is going to be look for alphanumeric characters only. And alphanumeric means letters and numbers. So anything from A to Z and 0 through 9 is an alphanumeric character. So we want to keep that. And everything else, underscores, comma, space, dash, we will get rid of it. So once the string is formatted according to our needs, we have that level playing field. Now we just have to see, does it read the same forwards and backwards? So in the end, I think our return value is going to be a comparison of the string to its reversed self. And I'm using triple equals here for comparison in JavaScript. So if the string and the reverse string are identical after we've cleaned them up with lowercasing and alpha and only looking for alphanumeric inputs or alphanumeric characters, we return a comparison of that string to its reversed self. And if they do match, if they're identical, then this will return true and these test cases will pass. And then if they are not identical, it will return false. And so these test cases should pass. Okay, so this sounds like a decent plan of attack to me. We took our time. We haven't written a single line of code except for comments. And now we can try to execute. The first step is consistently casing every character. I chose to lowercase our input. You can uppercase if you want, but you'll have to make a slight modification in step 2. So I'm going to go ahead and do const alphanumeric only equals, and we'll start with string.to lowercase. So now we have a lowercase version of our string. We don't have to worry about if something in the middle is capitalized or something at the end or the beginning is capitalized. All characters in our string are now lowercase. So that is step 1. Step 2 is to look for alphanumeric characters only. We need to dive a bit deeper here. Like we said, alphanumeric means letters and numbers. I'm going to open the Chrome DevTools here, and I'm going to give you some examples of the match method. Whoa. Let's just clean that up real quick. So let's say, for example, you have my name equals Yazid, all lowercase, because we know that our input is going to be lowercase. We have that guarantee in place. You can do my name dot match, and you can put a string as the parameter. You see, it takes one argument. It could be one of two things. The first type, it could be a matcher. The matcher is going to be a string. So if you do match E, you find an E here. Now, match takes a string or it takes a regex. A regex is short for regular expression. And the main difference in usage is instead of using these quotation marks, we're just going to use these forward slashes. And this lets you do a regex. So you see we get back the exact same result. At index 3, right, 0, 1, 2, 3, we have the first E in Yazid. But what if we want to find every E in my name? Because I have 2. Well, if we did a string, it wouldn't be as easy. With a regex, you get access to some special superpowers. After this last slash, you can put what's called a flag. And regex has a few flags. The one we're going to use is called the G flag. G stands for global. Global means find me every single match of whatever's between these slashes. So we put E. This is going to find every single E. And instead of getting all this with the E, the index, the input, the groups, if you put a G flag and you hit enter, you get back just an array of matches. So my name has 2 E's, like we said, so you'll find 2. If you put in like an A or a Z, you only get back an array of 1, because I only have 1 A and 1 Z in my name. So match takes either a string or a regex. And I'm thinking we're going to use a regex to find all the alphanumeric characters, because regex in general allows you to pattern match on strings in ways that you can't just do with other strings. So this is the regex I was thinking to use. Again, you could have found this by Googling. myname.match. We're going to need the G flag because we want to find every instance of this. We're going to start with opening and closing brackets between those slashes. These brackets are what's known as a character set. A character set says match whatever lies between these 2 brackets. So if we find this, this, or that, whatever's in here, it's going to be considered a match, and our regex will pick it up. Our regex will be this: A to Z. This means all lowercase letters in the alphabet, or 0 through 9. Or rather, A to Z and 0 through 9. So find me any letter in the alphabet, lowercase, and find me any number from 0 through 9. And this, by the way, is the definition of alphanumeric, because alphanumeric means letters and characters. So this is every possible lowercase letter in the alphabet, and this includes every possible number. For this algorithm, we're not concerned with the uppercase because our input is lowercase before we even do the matching. So we don't have to search for uppercase letters. If we did want to search for uppercase letters, like for example, if you did string.toUppercase, then instead of this, lowercase A to Z, you would do a big A and a big Z, uppercase. But for what I'm doing, everything is lowercase, so I'm only looking out for lowercase letters. And now you can see YAZEED. This just found every single match, every single letter in my name. Now let's take one of the test cases just to show you, like this crazy one over here with all the zeros. We'll copy this. We'll put it in a string. Dot match. Put our regex A to Z, 0 through 9, character set, and boom, 0, 0, 0, 0, which reads the same forwards and backwards. Let's go ahead and try this out. I'm going to copy this. So we're going to lowercase the string. I'm going to space this out so it's a little easier to read. Now we're going to call dot match. Lowercase the string and match for all letters and all numbers. Now remember that when you do this, when you call dot match, you get back an array of matches. So how are we going to use this array? Again, this is easy to Google. If you had 1, 2, 3, you can call reverse on it. And reverse is, as the name says, is going to flip your array's elements around. And this seems useful to our algorithm's third step, because we want to find the reversed string. So since we do 2 lowercase and match, and we get back the array of matches, if that reads the same forwards and backwards, then it's true. So that means we're done, and step 3 is complete. But comparing arrays is not as straightforward as comparing strings. So why don't we convert our array of matches back into a string? Luckily, all JavaScript arrays also support a method called join. This function stitches your array's elements together. So if I call 123.join with no parameters, I get 1, 2, 3. See, it basically took all this and stringified it. And these commas are unnecessary though, so we can take advantage of join's first parameter, which is the separator. You can see this question mark on the separator means it's optional. So we don't have to put it. You can see it still works. But if you do put it, whatever you put in here as the separator, my separator, it will get interspersed between each element. It gets inserted between each character of your newly joined string. So if you do a comma, you get a comma. If you do a comma with a space, you get a comma with a space. If you put sandwich, you get 1, sandwich 2, sandwich 3. But it's not time to eat yet, so let's just put an empty string. If you put an empty string, that's equivalent to nothing, basically. So it literally means put nothing between each character, which this seems like the cleanest way to format our algorithm. Now let's try this one out. Race car dot to lowercase dot match, and we'll give it our regex of A to Z 0 through 9 as part of a character set with the global flag. We get back RACECAR. Now if you call dot join empty string, you get the word back, because we took all of these characters and stitched them back together without any kind of separator in between each one. So if you do match and then join empty string, this essentially recreates the word, but now it's normalized without any crazy characters. Like even if you did this, space it out, do this, you still get back race car because we're only matching for alphanumeric characters. So now if you do this, you get back race car. If you do this, you still get back race car. See? So the array of matches, whether you read it forwards or backwards, you still get race car. So this is a palindrome. If you did it with, for example, my name, if you joined it, you get Yazid. If you reverse it, you get Dize, so it's not a palindrome. So these two are not equal, therefore if you input my name into the algorithm, you should get back false. So let's try this out. So we have our matches, to lowercase dot match, in a variable called alphanumeric only. So I'm going to say return alphanumeric only dot join. So now it's a string. And see, does it equal? Is it this exact same? Is it identical to the reversal of that joined as a string? Let's run our tests. And boom! Looks like we have one. Let's go ahead and review this one more time. So this palindrome function, it takes a string as an input. So for example, we took this. Let's use this one. A man, a plan, a canal, Panama. This is a palindrome. So if you open the Chrome DevTools and you just start applying all the work we do to this string. So we'll say input equals this string. And if you do input dot to lowercase, you now have everything evened out. A man, a plan, a canal, Panama, every character is lowercase. Now, on top of that, if you chain our dot match function, regex, character set, all lowercase letters, and 0 through 9, globally, so we find every match, we now have all of the letters without any of the punctuation, without any of the spacing. Now all you have to do is say alphanumeric only. We'll set it equal to that. And then if you do alphanumeric only dot join empty string, you now have a man, a plan, a canal, Panama. And if you reverse those matches before you join them, you get the exact same thing. See? This is a palindrome, where, for example, if your string is one of the other test cases, like I remember it was not a palindrome, and you run the exact same code again, input to lowercase match, you get all this. And now if you join, you get not a palindrome. If you reverse and join, you get a more nillipaton, which is obviously not a match. So those two are not identical, so you would return false. And then by returning that comparison, all of our test cases passed. I hope this was fun and informative. I hope this made sense. Please let me know if you have any questions. I'm on Twitter at YazidB. For more info, go there and check out my website, yazidb.com. All the links will be in the description. I hope to see you in the next video. Thank you for watching.